Here's a hypothetical method that tries to figure out if today is your birthday or not. And it tries to make use of the exception that if you happen to have been born on February 29th of a leap year, then in most cases, your birthday could be considered as being on March 1st. Otherwise, you'd only have a birthday every 4 years, which is terrible. So what would be some, if somebody just handed you this code and say, OK, your job is test this method, what are some general challenges that come up in trying to test the method? Was that a hand, or was that? Yeah, go for it.
Today is always set to the current date.
OK, so one issue is that the very first line of the method retrieves like whatever today's date is. So does that mean that if you test it, the results of the test are going to depend on what the date is? Any other challenges? So that's absolutely true, and we'll deal with that. Other challenges? Yeah.
Birth dates might not be like the correct object that we call month and day on.
OK, so what if someone calls this and the thing they pass as birth date is not something that has methods month and day? That's reasonable, but let's assume for the moment that there's some test someplace else that makes sure that when we call birthday today, it gets past the right kind of thing. So it's a legitimate concern, but let's say we can assume that birth date is a legitimate date object. Anything else about this that, if you wanted to simplify testing it, what might you do? So for example, under what conditions can this thing return true? Well, one possibility is just simple match. The other possibility is sort of this corner case. So probably if your job was to test this, you would think that you at least need to write one test to check each of these possible code paths, right? And as we're going to see much more when we talk about refactoring, usually when I see something like that, if I see a function that I'm trying to test, and what I'm seeing is, there's sort of 2 or 3 quite distinct things that could happen here, and my test somehow needs to make sure that I hit each of those distinct things. To me, that says this should have been 2 or 3 distinct functions, right? So I can imagine having some helper functions. One of them just sort of handles the straightforward case. One of them handles I guess what I'll call the edge case. And I could test those functions separately. And then all I really have to do is test the shell of the function, which calls the helpers. So we'll talk more about that idea of decomposing a more complex function into simple ones. But for now, let's deal with the one that came up first, which is how do you sort of break the dependence on something like this on a day of the week? Or in general, how do you test code in isolation if it has dependencies that would affect the test? And in the example that I gave just now, the dependency is a little bit weird because it's a dependency on what appears to be what the date is. But there are dependencies that are much more mundane and that you still have to deal with. For example, if you're testing a function that calls some other function, you don't want the results of your test to somehow depend on whether the function that it's calling is broken or not, right? In some sense, you'd like to be able to make certain assumptions about the helpers, and that's what we're going to talk about today and Thursday. Seams. Remember seams. Because seams is how we do the dependency breaking that allows us to get a little further in this test. What is a seam? A seam is a place where you can change something about the behavior of your app without changing the source code of your app. This is from the best book ever on working with legacy code, by the way. And I'll show you an example of how we're going to, and by the way, it's called a seam because you can imagine, like in clothing, you can imagine like temporarily unstitching something at the seam, sticking something in there, and then maybe stitching it back together later. I guess that's how it got its name. But the idea is that there are certain places where you can do things that change the behavior of the app without changing the source code of the app. And I'm about to show one of those and how it works. The reason that seams are important for testing is exactly that they allow you to isolate the behavior of code that is not part of the test, but is dependent on by the thing that you are trying to test. So we're going to show a seam that is based on the same use of expect, but basically it's a seam that says, I'm going to call some piece of code in my app. What I expect to happen is that piece of code is going to call some other function to do some work. Now, that other function that does that other work, that's not what this test is about. This test is to make sure that when the user submits the form, the right thing happens and that other function actually does get called. So the only expectation I care about for the controller method is, will the controller method call that method in the model? I am not testing that the method in the model does the right thing. We could have a separate test for that we create later. But what's the controller's job? The controller's job is receive the form and make sure that it passes the right thing to that downstream method. That's what the test is about. And the reason that this is kind of cool is because we haven't written the class method yet. The method that's going to do the work, we're going to pretend that it exists. That's why I sort of call this approach the code you wish you had. We wish we had a method that was already defined in the movie class that actually did this work. We do not have any such method, but amazingly, that does not prevent us from writing a test for this controller, because all we're checking is, if this method existed, does the controller do the right thing in terms of calling it? Okay, that's where we're going. So this is a really, really useful concept. That kind of an expectation is called a stub or a double or a mock. The terminology varies, but we'll hear all three. And just like with preconditions and anything else, we're going to set this up for a specific test case. But once that test case has run, anything we do with this seam is going to go away. Okay, so that's kind of the preview of what we're about to do. So we've established that calling the actual, doing the actual search in TMDB is the model's job. We're going to have a class method that does it. And let's assume that that class method, if it existed, had this useful name, find in TMDB. So what we're going to do is fake the ability to call the code we wish we had. So here's the strategy. We're going to simulate posting that search form from the controller. This is something you've already, this is what Cucumber does when you say, when I press a button, it just submits the form. Then in our test, we're going to check that the controller action that receives that form tries to call this method, and that it does so with the data that came from the form. OK, so the test is actually doing something useful, because you can imagine, let's say that the way you wrote your view, the field that the user fills in with what to search for is called movie title. But then when you're writing your controller, you accidentally think that it's called title, and you look for the wrong thing in params. Right? That's an example of the kind of thing that could go wrong, because the code is touching both the view and the controller. So we're going to check that the controller action not only tries to call this method, but that when it tries to call it, the thing it passes to the method is the right thing, that it's actually the same data that the user filled in on the form. Of course, this test will fail, because right now we don't have any code in our controller whatsoever. And then we can easily fix the controller action to make it pass. Okay, but the key thing here is we're isolating what the controller's job is. Right? We're not making any claim that this method exists or works or anything. We're just saying that if it existed and it worked, we want to make sure that it gets called at the right time and gets called with the right argument. Okay, that's where we're going. So here's how we do it. And there's actually not a whole lot going on here that you haven't already seen. So line by line, describe, that's just used to group together a set of related examples. Here's our first example. It calls the model method that performs the search. And here's the thing that's new. Expect movie, and remember movie is a class, and we said that the method that we wish we had would be a class method in the movie class. So expect the movie class to receive a call to a method called find in TMDB with a particular string passed as an argument. Why are we saying this string is passed as an argument? Well, let's take a look at the next line, and then I'll explain why these lines are flipped in the order they are. Here's an RSpec construct that says, do a post to this action in the controller and pass this exact thing as the params hash. Right? So this is the line that actually does the acting. It says, generate a form post to this specific controller action. So it bypasses routing entirely. We're telling it the exact method in the controller to call, and make the params hash look just like this. Because the idea is that if the user had actually filled out a form and the name of the field was search terms, and the user typed the word hardware, then what we would want the controller method to eventually do is to pass that value down to find in TMDB. So let me pause for a moment so you can sort of ingest a little bit of this. And let me ask the question. This expectation, this is an assertion, right? The expectation is I am checking whether a particular thing is true. In this case, whether this call happens and whether it gets this argument. So my question is, why does the expectation look like it's coming before the action? Usually it's supposed to be arrange, arrange, then act, then assert. But here the assertion comes before the act. Why is it necessary to do it this way? Anybody want to give it a try?
Well, since it's like trying to simulate a function, you wouldn't actually want to do the thing the function's supposed to do until you're sure that function actually got called.
I think try that one more time. I think you're on the right track.
Like, because like you need to call the function and then get the results of calling that function, and you wouldn't want the results to come if it didn't actually call the function.
Okay, so let me paraphrase what I think you said, and I'm going to use the term that you will probably hear used in the testing literature. In general, if I want to make sure that some function gets called with a certain argument, what I really want to do is I want to spy on that function. So in some sense, I want to be notified. If someone tries to call that function, I want to hear about it. Right? That's kind of what I'm saying here. So Ruby provides a way to do this. What happens when you set up this toReceive is that it actually sets up a fake method in the movie class. It temporarily defines a method with this name, but the method doesn't actually do anything except wait to see if it gets called. Okay, so it sets that up. Now the rest of the code inside the test case runs, and by the end of the test case, the testing framework can query this fake method that it set up and ask, hey, did you get called or didn't you? And if you did get called, was this the argument that you received? So in some sense, because we know we want to spy on the method, we have to make that statement in advance. Otherwise, if we didn't say this first, then the method would get called, but there's no way to ask, was it retroactively, did that method get called or not? It's too late. Whatever happened, happened. Right? What we need to do is essentially set up a watcher so that if the method gets called, we can immediately note that fact. So that's why it looks like, in fact, it looks like the assertion comes before the act, but this part isn't really checking the assertion. It's just setting up a condition saying, OK, by the end of the test case, see that this happened. If it hasn't happened by the end of the test case, then that's an error. Then the expectation has not been met. Does that make sense? It's a little bit hard to get your head around the first time you see it, right? But that's why the assertion in this case has to come before the action is taken. Because you can almost think of this as setting up a precondition that we're going to spy on that function. Later, when we talk about JavaScript and the way that you do some of these same things in Jasmine, which is the JavaScript testing framework, they actually have a term called a spy. And what you do is you create a spy, and you alias the spy to the thing that you want to see called. Now, keep in mind that the only thing this controller method is going to be responsible for doing is calling find in TMDB. This find in TMDB method doesn't actually do anything, right? The only thing it does in this test case is it verifies that it got called or not. But there's no functionality in there. In fact, I'll go you one better. And even if this method did exist, right? So now imagine that it's 2 weeks later, and some other developer on the team has actually coded the real find in TMDB method in the movie class. This test case is still going to stub it out. So the way that this test is going to work, even if there's a real method with this name in our app, this test case is not going to call it. It will still set up a fake version of the method and verify that the fake version of the method got called in a certain way. It will not even touch the real version, even if it's there. So my question, and it's not a clear question, it's just a let's put on your testing hat, why is that a reasonable thing to do? Even because you might think that once this method has actually been coded in the app, that we sort of don't need this anymore. Why would I advise keeping it in despite that? Thinking about isolation, what would be an argument for keeping this test the way it is, even after the real find in TMDB method has been implemented and we know it's working and stuff like that? Why do I still probably want to keep this test case just like this, calling a fake method? Give it a try.
Well, this test is for the controller, right?
This test is for the controller.
You don't want to have the controller test be dependent on that other test.
That's right. It's test independence, right? The only thing I want to test here is if the controller is doing the right thing and trying to call the right helper. I don't want to make that test somehow dependent on the helper itself. What if the helper breaks at some point? What if the helper takes a long time to run? But just in general, anything I can do to isolate my code that I want to test from all the other things it depends on. Okay, so that's why it's important that when you do something like this, right, what have I done here? I have set up a seam. I've basically said, at the place where find in TMDB exists in my app, if it exists at all, open up that seam and stick an observer in there so that for the purposes of the test, the real find in TMDB will not get called. In fact, I don't even care if it exists. I just want to know that something with that name got called with those arguments, and that's it, end of story, right? And of course, in real life, this test would never work as part of a full workflow, right? In a Cucumber scenario, you couldn't do this. You need to call the real find in TMDB because the scenario is going to do a workflow that has many steps. But in a small test like this, where you're checking a limited amount of stuff, you stub everything, pretty much. A very related concept is a double. And double in this context means, think in terms of movies like a stunt double, someone who is a stand-in to do a dangerous thing when the actual actor is not supposed to be doing that thing. So going back to this controller method, this hypothetical controller method that we're writing a test for, the first thing we said is the controller method should call the find in TMDB function to get some results. And the second thing we said is once it has those results, it should make them available so that some view can potentially show the results to you. So again, you're going to see a lot of RSpec and RSpec Rails documentation, but I will just tell you for the moment so that we can think about, sort of focus on strategy here. There's a method provided for us in the testing framework called assigns that basically lets us ask, did a particular controller instance variable get set, and what is its value? So remember that the controller instance variables are the ones that become available in the view so that you can incorporate them into the view. So basically what we want to do is not just check if the controller action is calling find in TMDB, but it's setting some variable that the view will actually be able to get to. And of course, the version of the code that I said before, look, this is just enough code to pass the test. Well, that's true, but it's not going to pass a test that looks for assigning the result because we're not assigning this result to anything. We're just sort of calling this method and we're throwing the result away. So the question is, in this case, back to the idea of, OK, what's the code we wish we had? Well, the code we wish we had might be something like this. There, that's better. Something like this. Ignore that intermediate stage. Where we're not just calling this method or a seam for the method, but we're actually assigning the result to something. Because in real life, that's what we'd want to do. So we are now in the position of needing to write a test that actually checks if this variable is getting assigned to. By the way, that's different from checking if find in TMDB got called, right? It's possible that the return value from find in TMDB might go through some other intermediate processing and then ultimately get assigned to some instance variable. So our test is really just concerned about does it get assigned to some instance variable in some reasonable way. And a way that we can check that is another type of seam the testing framework provides. Depending on who you talk to, some people call it a double. Some people call it a mock. There's a particular method that we're going to use to create it called instance double, which, given a class name, gives you a stunt double instance of that class. Now, the stunt double is actually pretty stupid. It can't do very much. In particular, it doesn't know anything that the real class knows. Kind of the same way that the expectation creates a fake version of the find in TMDB function. That fake function doesn't do anything, but it exists sort of as a placeholder just for answering the question, did I get called? This is the same idea. It's going to create an instance of a class that looks just like. If you ask it, are you an instance of movie? It'll say yes. But it can't do anything that a movie can do. It doesn't know about the accessors. It doesn't really know about any of the behaviors. We have to endow it with the specific behaviors needed for our test. So like any other kind of seam, the goal is give you just enough functionality to test some specific behavior. So in this case, what would that mean? Well, we could set up an instance double of the movie class. And we're going to stub a few of its methods. To stub a method is kind of what we did in the test. It's to create a fake version of that method that exists and can be called, but doesn't really do anything necessarily. So to stub it, we're going to say allow this stunt double to receive, in other words, to have the method title called on it. And if it's ever called on it, it'll return some canned string. Okay? So we're basically creating a fake object. And when you call a method on that object, we're controlling the return value. And similar to the other seam that we saw, you get the method name. You can specify a canned return value. There's also a syntactic shortcut where at the time that you create the instance double, you can provide some key value pairs saying, if this method is called, return that canned result. Right? So again, it's a really, really, really not very smart object that is going to be used just when you need a stand-in with very limited abilities. Right? So what are the abilities that we need in this case? Well, if we're just passing it to another method, if we know how the stunt double object is going to be used, we'll just define simple behaviors for those particular methods and nothing else. So what is this going to look like? Going back to our test case, within our test case, we're going to create a list of fake results. If the find in TMDB method really existed, what would it probably return? Well, it would probably return some collection of movie objects that are the matches it found in the database. So we're going to create an array of 2 of those things. Each one is an instance double. These instance doubles actually don't do anything. All they do is sit there and look like movies. If you ask them to do anything that a movie does, like tell you their rating or something like that, you just get an error because they're not real objects. They just look like them. Nonetheless, we can create a set of those, and now we can say allow the movie class to receive find in TMDB. That part we've already seen. But we can augment it with and return something. So this says if the movie class receives a call to this method, here is what to return as the canned result of that method call. So I kind of think of this as those machines that used to be popular in gyms, but I think they're not anymore. They used to call them Nautilus, but it's the one where like you can isolate like just this muscle of your forearm by doing it enough times, right? That's kind of what these tests do. You're isolating, you're holding fixed everything around your test code and providing just enough behavior with these stunt doubles to test the one thing you want to test. And then, after you've done the post, the controller action has been called. Now is the assertion part of the test. We're expecting that the instance variable movies got assigned, so the controller set a value for that variable, and that value equals the thing that ultimately got passed to find in TMDB. Now, it looks like for a really simple controller method, this is overkill. And I needed to choose a simple example just to show you how this machinery works. But the general idea is always the same. Anytime you're testing a function and that function has an external dependency on something, if the dependency is on an external method, even if it's in the same class, you can say allow to receive, and you can can the results of what that method is going to come back with. So this is a way to isolate your testing very cleanly, even within the same class. How come here, instead of saying expect movie to receive, I'm saying allow movie to receive? A subtle distinction, but an important one. Anybody want to take a look, take a guess, take a crack, What's the difference, just in terms of what the word is saying? And I know you've not seen the syntax and stuff, but in terms of expect versus allow, what's kind of the difference between those 2 statements? Expect movie to receive a call, allow movie to receive a call. Go for it.
Maybe with respect, with expect, then it's like false if it doesn't happen, whereas with allow, then it's...
Exactly right. So if I say expect movie to receive some function call, then it is an error if the test finishes and it hasn't received that call. If I say allow movie to receive a function call, what I'm actually saying is whether movie receives that function call is not the thing that I'm testing. And in fact, it might receive that function call 0, 1, or some other number of times. What I really care about in this test is the last line. Expect is the only thing that makes the test really fail or not fail. So if at the end of the day, the movie's instance variable of the controller has been correctly assigned to fake results, this test doesn't care if that happened because movie received this call or if it happened some other way, right? This particular test is just checking whether it got assigned correctly. So you can say expect to receive or allow to receive, but that's the difference. If you say expect to receive, you're saying this test should fail if it doesn't happen. Allow to receive means it may or may not happen, and whether it happens is actually not the point of this test, but if it happens, here is what to do. So the question was, is there any way for movies to be assigned to fake results other than this actually happening? In this simple example, probably not. But there are examples where basically you're setting up some. So this is, if you remember the pattern of arrange, act, and then assert, this is essentially the arrange part, right? This is setting up a precondition or setting up the world such that if a certain method gets called, it can return a canned result. In real life, there are going to be cases where, in some sense, the distance between this setup and the expectation is much larger than in this really simple example. So in this really simple example, I'm hard-pressed to think of a way that the expect could be true without movie having been called. But in real life, it happens all the time, right? And really, when you use allow, what you're saying is, I prefer to be ignorant of the implementation. I'm just thinking that this thing could be called, but it's not part of the test. But you're right. In this very simple example, it seems a little contrived. I agree. by the time we get to this line of code, the expect line, the controller method has finished executing, and presumably that means that all the state associated with the controller has been incinerated. So how is it that this assigns method is basically able to check the instance variable? TLDR, the test framework essentially hooks into the controller, and before the controller method is allowed to relinquish control, there's a way you can ask an instance of a Ruby class, tell me all of your instance variables and their values. So it uses introspection. Before the controller instance is incinerated, it asks the instance to list all of its instance variables, and it just basically has a big hash of them. And then it just looks up in the hash whether this one is set or not. What does the scope of this allow? The scope of allow, expect, doubles, anything you do in a test is just between the it and the end. So once this test case finishes, everything we've done in here to set up seams is blown away. And any other test case that wants to do the same thing has to either repeat this line, or you can pull it out into a before block like I showed last time. You can have a before block that applies to several different test cases. Good questions, though. Each spec, which is one way to talk about a particular test in RSpec because it specifies a behavior, should test just one thing. And ideally, you use as many seams as necessary to isolate that behavior and control all the ways that it can go wrong. What kind of expectation? So what is the thing that you're checking? What is the one thing you're checking? And in an ideal RSpec test, there will be exactly one expect, right? Because if there's more than one, then you're maybe testing more than one behavior. And if there is 0 expects, then the test is not asserting anything, so there's sort of no way for it to fail. Make sure the test fails for the right reason. So what would be a wrong reason? Well, syntax error, that's a wrong reason. Or you're trying to call a controller method that doesn't even exist. That would be a wrong reason. Once it fails for the right reason, now you're in good shape, because all you have to do is add code until the test passes. And believe it or not, that's actually the easier part of the job. Structuring your code so that you can write tests that test one behavior each is actually the more challenging part. Okay, so that's basically it. So where are we with RSpec? We've learned about using expect or allow, and you can either say expect a class to receive a method call or an instance of an object, right? I can create a movie object and say expect this object to be asked its title, and when it does, return a certain value. I can make a double, which is really stupid, but then I can tell the double to implement specific return values for methods that it's called. And in the RSpec documentation, there's a whole bunch of other expects that you can do. You can expect an object to match a regular expression. You can expect a collection to include or not include a certain element, and so forth. And there's a number of Rails-specific extensions like assigns to see whether the controller assigned a certain variable or not. There's also response, which models the response object. So you can ask things like, if I call the controller method, it should do a redirect at the end, right? You can ask the response whether the response is a redirect or whether it's just a normal payload being sent back to the client, things like that. Okay? So again, that's the idea of what we're, and we saw and return, which allows you to control the return value but is not mandatory. If you don't say what return value you want, then the function will just return, the fake function will return nil. All right? And these are the ones that we used in kind of our most recent scenario.